In this video, an ENACT coach will model 2 strategies teachers can use to support students in taking ownership of computational thinking practices. We call these strategies prompting and pointing out. The coach will model how you might prompt students to use computational thinking by making suggestions about how students can use a CT practice to approach a problem. Then the coach will model how you could point out when you observe a student using CT practices, whether they realize they were doing so or not. The examples in this video focus on plotting polygons on a 4-quadrant coordinate grid, but the ideas could apply to any problem that could be broken down into smaller parts. Let's watch an example of the coach prompting students to use decomposition. The class is having difficulty starting the problem, and the coach suggests using decomposition as a strategy to identify how to get started.
It sounds like a lot of you are having trouble getting started on this problem. So let's talk about that a little bit. So this problem asks you to do 3 things for each of these polygons. You need to find all the coordinates of the vertices of the polygon, draw the polygon on a coordinate grid, and then find the area of each polygon. So one of the things I heard a lot of the groups doing is trying to focus on just one of those parts at a time, which is great. You were using decomposition. You saw that the problem was already broken down into parts, and you were focusing on just one part. But then some groups shared a frustration with me. They said, we tried each of the parts, but none of them really helped us get started on the problem. So for example, looking at that first part, find all the coordinates of the vertices of the polygon, they said, I'm just not really sure how to do that. Is anyone else feeling that way? Yeah, I agree. It's not really clear how we find those missing coordinates. So maybe start with a different part. Draw the polygon on a coordinate grid. Well, if we focus on that one, it seems like we can't do that until we have all the coordinates, right? So maybe not starting with that part either. What about that third part? Find the area of each polygon. I don't know, it seems like it'd be easier to do that once we've drawn it on the coordinate grid, right? So there isn't really a good piece to start with this problem when we're just looking at these 3 pieces. Kind of frustrating. But I have an idea for all of us to try. What if we decomposed even more? So even though this problem is already in parts, can we break any of those parts into even smaller pieces and maybe just do some of them? So instead of finding all the coordinates of the vertices of the polygons, is there even just one in here that you have a strategy to find? And maybe you can't draw the whole polygon on the coordinate grid yet, but are there parts of it you can draw? And what about the area of the polygon? Maybe you don't know how to find the area of all of these, but is there a strategy you have to find the area of just one of them? So talk to your group about that. Is there a way you could decompose even more to get started? Talk about it and we'll come back together in a few minutes.
Bringing students back together after they've had time to discuss ideas with a partner provides an opportunity for students to share feedback and can help you ensure that all students have a way to get started on the problem. Now let's watch as the ENACT coach prompts students to work with a partner to debug their problem and check their answers.
Great, so it sounds like everybody found a place to get started putting your polygons on the coordinate grid and finding the missing coordinates. Now I know it might get a little confusing because sometimes you have to start with the coordinates and put the points on the coordinate grid. Like for A and B, you have the coordinates and you're probably just going to write them and plot them right here. But then for other ones, you might be plotting it on the grid and then having to go back and write your coordinates in the list. Like for point C, you know you're trying to make a square, so you might decide that point C should be 3 units above B, and then you have to figure out what those coordinates are and write them back on your list. Plus there's just a lot of stuff to keep track of. Each point has a different letter, and you have to keep track of which one's the x coordinate and which one's the y coordinate. It's a lot, so you might make some mistakes, which is fine, but it's also important to think about how you're going to catch them. So what kind of debugging strategies are you going to use? Here's one idea. Maybe after you've finished writing all your missing coordinates in a list, you can give your list to a partner, and your partner can just plot them. So then your partner isn't going back and forth, they're just plotting all the points. And then they can check if it made the shape that you meant for it to make. If not, you can work with a partner to find the bug.
A focus on debugging provides many opportunities for students to work with partners and small groups. Two heads are better than one when it comes to improving work. Now let's watch as the ENACT coach is pointing out how a student used debugging to check their answer while plotting points on a coordinate grid.
That was a great debugging strategy, Dakota. Do you mind if I share it with the class? Thanks. Okay, so Dakota was working on this problem, trying to find the missing coordinate in this blue point on the bottom here. So the x-coordinate was missing, and Dakota knew that the x-coordinate would be the point on the x-axis that this point lined up with. But the way this was drawn, the rectangle was covering up what that number would be. So the first thing Dakota thought is that maybe it's 11 because it's coming right after 10. But then Dakota did something I thought was really interesting. They looked at the rest of the information in the problem just to make sure everything was making sense together. And Dakota noticed that this point up here was right above the one she was working with and had an x-coordinate of 12. And Dakota thought, those should really be the same. So maybe that missing coordinate should be 12. So she looked again at the x-axis and realized these were all numbered by 2s, not by 1s. So it made sense that the missing coordinate would be 12, not 11. Thanks for letting me share your debugging strategy, Dakota. Is there anything you wanted to add?
Even if some students don't want to share for themselves, asking if they have anything to add can make sure their voice is heard. Let's watch one more example of a coach pointing out how a student used decomposition to find the area of a polygon.
I was walking around as you were working, and I got to hear a lot of your thinking. Thanks for sharing your strategies for finding the area of this polygon. Did anyone use decomposition to find the area? How did you decompose the shape? Okay, so you thought of this polygon as being a big rectangle with triangles on the top and the bottom. Okay, and you found the areas separately and then added them up? Okay, great. Did anyone decompose in a different way? Oh, okay, so when you looked at this polygon, the first thing you saw was these squares on the side, so you started with those. All right, and then after you found the areas of those, what did you do? Oh, so you had to decompose even more. So that middle part, you decomposed into a square and 2 triangles, so you could find the areas separately. Great, and then you added it all together. So there's more than one way you can decompose this shape. There's usually more than one way you can decompose a problem. Maybe next time you're using decomposition, you can challenge yourself to decompose the problem in more than one way.
As you plan to prompt and point out how students are using CT practices, consider these questions. What are some strategies my students could use to solve the problems in this lesson? How might a CT practice already be a part of or add to those strategies? How might I recognize when I see my students using a CT practice? And how might I identify when it would be helpful to prompt a student to use CT?